Tuesday, we'll hear from Michael Nathanson, who will describe quantum computation.
Thank you.
So if you're interested in quantum computing, please attend next Thursday's colloquium. Then I have the distinct pleasure of introducing you to Tim Doughty, who was one of you a few years ago, and he's going to reveal deep secrets about what worked and what didn't. Let's salute him.
I recognize some of you from 115 and other classes. So how are you all doing?
Good.
So I work for a company called DriveSavers. They do data recovery. Fortunately, most of what I've done can't be yet made public, so I'm here to talk about general retrospective of Sonoma State, things that have helped, things that I wish I'd learned before I started working in the real world. So let's see here. Step one, biomechanical keyboard. Jokes aside, one of the biggest transitions I've noticed was going from 3-hour lab, occasional time in the dungeon after class, to a 8-hour a day, 5 days a week job. It's really different. So you want to be comfortable. So find a keyboard that you like, whether it's ergonomical, what have you, a good chair, because if your back hurts, your wrists hurt, you're not going to program well. And you want to program well because you don't want to get fired, because that's not good. One of the biggest things I've seen that has caused people to not do well is they make friends with the wrong people. I lost track of how many classmates I had get into pot and alcohol, and then halfway through the semester you never see them again. And it's like, well, where'd you go? It's like, I'm on academic probation. Whoops. So you want to make friends with good people. However, when you're working on a project with somebody, you want to make sure that you treat them kind of like a coworker. If they come hungover, as a friend, you're going to be like, yeah, I'll help you out. But if your coworker shows up to work hungover, you're not going to like that. It's not a pleasant experience. Also in the same category, never be afraid to ask them questions. The worst they're going to do is tell you you're wrong and then explain to you why you're wrong. Conversely, if somebody says, hey, I think you're wrong, don't get upset at them and fuss at them and yell at them, because that's not conductive to you. Basically, oh my God, I learned something new, the horror. Go to lecture, that's an important one. I have chronic migraines, and so sometimes I couldn't always make it to lecture, and miss a class. Not the end of the world, you miss 2 classes, starting to get a little bit iffy. Not a pleasant experience to get caught up, especially when you hit the 300, 400 level classes where things are moving so fast. Seriously. Oh, and if you have any questions, please feel free to interrupt. I have a feeling this is going to be like the Futurama. It took an hour to write. I think it will take an hour to read. Thank you for some of you. One of the biggest things I found is that glancing at the material ahead of time, so you have a general idea of what's going on. Because, again, especially when you hit the 300-400 level classes, things go fast. It's a lot easier to play catch up, fill in the gaps, than go, holy crap, what are you doing? Good. Meet up with good people. You probably have already learned who the smart people in the classrooms are, who the hard workers are. I found that a lot of times, a nice person is great, especially if they're a hard worker. How many of you guys have met a really smart person that happens to be a complete ass? Yeah, basically, it's not so much how smart they are, because CS is a hard subject, but as long as you are willing to bang your head against the wall, you're going to get it eventually. You might have to work at it 4 hours instead of somebody else doing it 1 hour, but as long as you're a hard worker, you're going to do it. On your project, start early. Literally one of the biggest things I found to help was, if it's a homework assignment, start on the first day. You leave class, instead of spending 2 hours playing Smash Brothers, spend an hour working on your homework, then play Smash for an hour. When I graded, it was ridiculously easy to tell who the people who did it in like the last 45 minutes rushed the project. I mean, it was just like, wow, you didn't really spend a lot of time on that. And the, Dr. Ledeen, the rest of your professors, they kind of learn that. And so, and I don't think, they're not going to be like, oh, you didn't work hard enough, screw you, go away. But if they notice that you're willing to work hard for it, they're going to be more willing to help you. And that's like, so important, is getting the professor's help whenever you need it to actually succeed. Yeah. Also, when you get it working early and you get it work and you spend the time on it early, it gives you a heck of a lot more time to, as the assignment gets closer, to finish it up, make it pretty. For you 115 students, or if you're in a revoir class, I mean, there's a reason why in 115 syntax was 35% of your grade. It's important. I mean, I've lost track of. I've spent 2 or 3 days attempting to go through code from big company code that has no formatting, no syntax, no comments, and you spend the entire time banging your head against the wall. It's not fun. So don't be like that. Be a good coder. Syntax, comments. They're your friends. Practice. Doesn't matter if you don't like the subject. Do it. If it's a subject you don't like, spend some time, figure out what you do like. I mean, how many of you have pets? Okay, how many of you have ever dropped them off at a daycare place that has a webcam? Somebody went, I like pets, I know CS, I'm going to stick a webcam in a daycare center so people can go online and watch their pets. Before that, you hope they were good. Now you can actually watch them play instead of working. Don't do that. Side projects. I've got a coworker who wants to build a game. I've started working on him, helping with an app to play this amazing tabletop game that sounds really fun. One of the reasons I did it was because it might help at a project at work later on. But it's a side project. It's fun. It's cool. You learn new things. If you don't like the assignment, you kind of still need to do it, but you use your dislike of the assignment to get it done early, and then you don't have to worry about it anymore, which is always nice, because you'll have people working like the last weekend just going crazy, drinking so much caffeine, just losing their minds because it's a project that you finished 2 weeks ago. I mean, you can go, oh yeah, sure, I'll help, or you can be like, I'm playing Smash Brothers, go away. Be a pig-headed, stubborn jackass, because sometimes your code doesn't work. You don't know why it doesn't work, but you have to fix it. Don't give up. I mean, it doesn't matter how hopeless you think it is. Doesn't matter how cryptic the debugging, what the debugger is giving you. You can fix it. You can do it. Some of the resources: Stack Overflow, Reddit, the programming subreddits. There's a couple hundred of them. Ask Reddit. Don't go on those. But like C++, I think has 13 by my last count. Python has about 8. So I mean, there's all sorts of resources out there. Most of the big languages and the frameworks will have newsletters with professionals all over the world, shooting off questions, answering other questions. Google them, find them, use them. Again, blogs. Coding Horror was one of the first blogs I found. It's a great blog, but I mean, there's so many other professionals who just take time out of their day, write crazy little random snippets of code, things that they've run into, and bang their head against the walls. They're there, use them. The cool people I told you to meet a few slides ago. If you have questions, they're gonna be willing to help you. Your professors are gonna be willing to help you. If you get stuck, don't fret. Everybody gets stuck. Just ask for help, get the help, and you'll be on your way. Some of the classes that I've found most relevant to my work is data structures. How many of you are in data structures or have had data structures? Literally being able to determine the best way to store and manipulate the information you're processing is so incredibly helpful. I I mean, a lot of the times, so for some of the small things, like if it's a standalone, quick, easy script, it doesn't matter if you really use a difference between a list or a hash table, you know, but for like the large things, when you're processing gigabytes and terabytes of data structures are so incredibly helpful. They make your code just so much better, so much easier to understand. And yeah, that's, if of all the 300 level classes, that's really the one that I would pay the most attention in. Multithreading, I know it's a elective, 385, it's amazing. And one of the great things about it is, you know, because if you've taken architecture, I'm sure you've seen the chart that said if we followed the linear pathway of improving processing power versus temperature, you know, we quickly hit the temperature of the sun. You know, we do multi-threading instead. Throw 4 or 5 cores on there, and then you can do 4 or 5 parallel processes. You know, same size chip, and you know, just makes your life easy because you know you don't have to worry about melting your computer. However, you know, you'll see a lot of people just go, oh, multi-thread it, multi-thread it. You know, sometimes you know, multi-threading's not the way to go. Like, I mean, if you're doing file I/O, I mean, the OSs have structured the way they write to disk because it's such a slow, painful, arduous process that if you multi-thread it, you might actually cause it to be slower because you're confusing the OS with what it wants to actually do. So keep it in mind, but don't always just go, oh, I'm going to multi-thread this to make it faster, because sometimes it doesn't go faster. But yeah, if you hit a bottleneck, multiprocessing, if you can figure out how to split that off into, you know, instead of doing everything on one thread, you know, if you're processing the data on multiple threads, it just makes your life a lot quicker because you know, you can do 4, 5, 8 threads at a time and process the data so much faster. And there's also, I'm sure if you ask Dr. Revor, she has a number of good books to use for multiprocessing if you can't make it to 385 or it's not offered. But definitely that's one of the topics I would look at because from what the test interviews and whatnot you see at Google and Amazon, Microsoft, multiprocessing is a big one. Algorithm analysis, that one was really fun. One of the better 400 level classes I've had to use. The one thing I've noticed that was very strange to go from the classroom where you know, you got it working and you made it pretty and perfect and then you turned it in, is in the real world you'll get something working and you'll be like, oh, I've got some improvements to make, and then you know 3 months later you haven't had time to make the improvements yet. So when you do get the chance to do them, you can make your code so much better, and you know, just changing around some loops, and it just makes your life so much easier. Yeah, there we go. But however, when it comes to grading and you know your project managers and bosses working code, doesn't matter if it's not as perfect as it could be. It's a heck of a lot better than you know really efficient code that just doesn't quite work. I mean, a lot of the times your code you know doesn't have to be, you know, if you miss a couple of things, you know, you hit some edge cases, you know, you're not going to notice them, but they can cause horrible bugs, make your life a living hell for weeks at a time. Don't do that. Get your code working. Make sure you're taking into account your edge cases and your crazy things. You know, if you're parsing strings and turning them to numbers, figure out what to do when somebody says football, because football's not a number. That doesn't work. Debugging. This is by far the biggest one. If you haven't debugged yet, go break your code and debug it. You will literally save weeks and weeks of hair-pulling frustration. If you're going to start with a new language, new IDE, new framework or API, figure out how to debug it. It's like literally the first thing you do. Because if you don't know what the debugger is giving you as an error message, you have no idea what's going wrong. So again, prevents hair loss, prevents wrinkles, because you don't have to be up at 3 in the morning going, why is my code not working? Because that will happen. Doesn't matter who you are, where you are. You will eventually have 3 a.m. pulling your hair out going, crap, it doesn't work. For you 115 students or Python students, this is the initial debugging code I've used. It spits out your error message, what type of error, the actual error that it is, and then it tells you which line you're barfing on. That's incredibly useful when you've got like 4 or 5 lines that you don't know where it is. Being able to pinpoint where it actually is very important. So yeah, if you're a 115 student, I'll let you sit on that. But yeah, I mean, again, it's debugging. You get into it a little bit in 252, and you'll deal with it, in all your various classes. But debug. I mean, I lost track of how many students 115. They go, oh, it doesn't work. Call you over and it's like, okay, it says index error. Okay, well, what could the index error be? And then you walk them through the code, and it's like, okay, index. Well, you're calling index 5. How many things do you have in your list? I have 4 things. Why are you calling index 5? I don't know. Okay, well, let's see here. Index 0, 1, 2, 3. There's no 4 or 5. So we have to figure out exactly how to adjust that. Whereas if you know how to debug it, you're going to get your labs done a heck of a lot faster, get to leave, go do really fun things, rather than sit in lab for an extra 3 hours trying to fight with your code. Yeah, when in doubt, if your code's not working, odds are it's your fault. Sorry to say. Odds are the OS, the API framework, those have all been debugged, thrown through QA. When your code doesn't work, it's probably your fault. Yeah, 99% of the time, it's on you. You have to go back to the debugger, figure things out. It kind of sucks, but you gotta do it. One of the things I found is, has anybody ever heard of rubber ducky debugging? Okay. I bobblehead Groot debug. I look crazy doing it. But yeah, I literally will sit there going over my code with a bobblehead Groot, telling him exactly what line does in English, line by line by line. I look like a crazy bastard doing it, but it catches so many bugs. I mean, your coworkers may go, what the heck? It works. Yeah, those cool people, your bosses, websites, your professors, your coworkers, ask them for help, get their eyeballs on your code. Because sometimes you've become so focused on the code, it's like, oh, I know that this code does this. When in actuality, you missed something, you're calling the wrong function. They're going to be able to come in with their fresh eyes and go, oh yeah, here you are. That's where you screwed up. You fix it, life goes on, you're happy. You get to go home. However, yeah, sometimes it is actually not your fault. After you've gone through your code a couple of times, you've got a fresh pair of eyes on it. Check to make sure that the API calls and any external code you're using, open source code you're using, actually does what you think it's supposed to do. I've had this problem twice so far, where the OS was not actually doing what it said it was doing, and unfortunately there's no way to fix millions of lines of code from one of the big OS people, so you actually have to go back and refactor your entire code to work around that bug. In one case, we realized it'd be such a big hassle that we went, oh look, this newer OS version does it. We're going to that one. And so we actually literally skipped 2 entire OS versions because there was no way to work around that bug in a reasonable amount of time. Yeah, so if your code works by itself, it's internally consistent, look at the other things. Now, it doesn't matter how tiny, if it's a single line of code that does something you think is very small, it might not be doing what you think it's doing. It doesn't matter if it's Microsoft or Apple or any of the big major companies. Their code might be screwed up. It might be that it got compiled wrong, and so the program you're calling is not working right because it's got an error in it. Check it. Nothing is off bounds. Never go, oh, Apple wrote that, that's golden. I don't have to touch it. Apple may be wrong. Probably not. Maybe. Look at the big picture. This is still like one of my weakest things, is when you look at the big picture, you start with like an entire project, and you have to break that down into manageable chunks. Whittle it down into smaller chunks. Usually, boss or project manager will do this, especially for the larger projects. but odds are, even if you get given a small like subset of a small project, you're going to have to do it anyway. You're going to have to figure out, you got to pseudocode it, you have to go, I need to do this, and then this, and then this, and you have to figure those things out. And being able to do that ahead of time, get everything pseudocoded out, and then actually start working on your code, I found is a heck of a lot better. Because you can write the code, make it do what you think, and then, oh, wait, I forgot about that one piece that I was supposed to do earlier, and then you have to go back and change all your code. That's not fun. So figure out when you can break your code down into smaller pieces, or not your code, but the project itself into smaller pieces. Also figure out when if you have something to do something, and you can push it off. Maybe it makes more sense to push that off to next week or the week after, the next sprint. And then focus on what needs to get done right then, right there. Again, don't lose sight of the trees though. When a lot of times you'll be working on a small piece of code and you'll be like, oh, but if I make this change, I can make this further change down the road that nobody else has thought about. Maybe don't spend 3, 4, 5 hours putting that change in. Maybe make a comment, say, hey, I think if we have to do this in the future, do this, this, and this. Put that in the comments. So if you have to do that, in the future, your boss goes, hey, that's a really good idea. Let's do that. Your code's not there, but you haven't spent, the half a day, the day, fixing code, making code that you don't actually have to use right then. Again, future improvements, always keep those in mind, but never make those the forefront of the problem you're attacking when you haven't finished attacking that problem itself. Smaller pieces also make it a heck of a lot easier to track your progress. Make sure you're getting everything done when it needs to get done. Normally, if you've taken 370, you've probably heard about agile, sprints, other things like that. Being able to track those small pieces and be like, we need X, Y, B, and Z to be done by the end of this first sprint. And then, next sprint you'll take on some more things. And then having those small chunks just makes it so much easier to keep progress, keep going, know exactly what's been done, exactly what you need to do. Specialization, this is a weird one. I've asked a couple of people and I've gotten very differing results for this one. It's great for job security. If you know how to code Haskell and your job requires Haskell and you're the only person who knows Haskell, odds are you're not getting fired because who else knows Haskell? COBOL, things like that. Some of the older languages, the specific frameworks, they're really nice for job security, but if you decide, oh, I don't like this place, they're not paying me enough, what have you, it's kind of hard to change if you've only been doing some obscure language that's not really used much for the last 5 years, and you've done nothing outside of it. Going from Haskell to Android development is a bit of a jump. Just because you're doing that specific thing for your job doesn't mean you can't spend some time, your free time, learning new things. Because that's one of the key things with software engineering is you have to keep learning. You can't just sit on your butt and do your job and expect to succeed. Because you'll be great at that job, but if you want to leave, you want to try something else, you're screwing yourself over. Coursera, they've got, I think, 30 currently running CS classes on their website of varying subjects. Khan Academy, O'Reilly, if you've ever been to Sebastopol, that's where they are. Go to their bookstore. It's awesome. Lynda, Udacity, these are all tools that you can learn in your free time. With O'Reilly and Lynda, they have audiobooks. You have a commute. Listen to one on your commute. You may not use it in your job, but you've picked up a new skill that's not only remarkable, but odds are it's pretty fun. This one is important. All of you, you're idiots. Me, I'm an idiot too. Dr. Ladine, Dr. Kshesh, at one point, they were idiots too. Your boss's coworkers, they're all idiots at one point or another. So, how to not be an idiot, it's literally ask questions, never stop learning. The moment you stop learning is the moment you stop progressing as a programmer, stop becoming a great employee. Experience, that's one of the big ones. Doesn't matter how smart you are in theory, if you can't actually apply that knowledge, you're not really much of a use to anybody. You need to get that experience. Internships. I highly suggest getting an internship. You're in between your sophomore and junior years, and especially between your junior and senior years, because it's experience. So those entry-level jobs that say this is an entry-level position, 3 or 5 years experience. So it's a contradiction, but you have experience, and it makes it so much more likely that you're actually going to get that interview. You're going to get your foot in the door. And then, more importantly, if you have internships at different places, you're going to figure out what you like to do, what you don't like to do. And so you're going to be able to go, oh, I don't like that. I'm not going to do that anymore. I was a bio major at first. Was going into pharmacy, have my pharmacy tech license, actually did a job shadowing at a pharmacy and went, oh, that's not for me. Switch majors. That's one of the powers of internships and getting your foot in the door and getting that initial experience. Yeah, you may not like it. You may be all gung-ho for being a CS major, becoming a software engineering, only to figure out that you don't actually like it. And then that's when you have to go, okay, what do I do? And you can't make that decision until you have that experience. Yeah, so you need to figure out what you want. Your CS majors, the world is literally your oyster. Again, webcams for dogs. 5 years ago, that wasn't a thing. Doesn't matter what you like to do, odds are somebody needs a programmer, an IT person, something to do it. So if you like playing board games, make an app. Maybe you want to join the company and be their system administrator. Work hard and party hard. This is one of the things that it's the main reason why I never even considered applying to one of the big 4 companies. Is there's a reason why they have all of those really fancy perks to keep you at your job. They're to keep you at your job. They're so you don't have to go home. How many of you have heard the story of Apple employees who spent so much time on campus that they actually just bought a cot and lived in their office? You have access to everything. Do you need to go home? But you need to find that what works for you in the work life, personal life. Because you're going to get burned out if you're working 16 hours a week. I had an offer for a job that paid stupid well, but it was one of the places that was very office space, and it was, well, if you don't work 12 to 16 hours a day, 5 days a week, we don't really consider you a team player. I noped out of that so fast. Because what's the point of going to work for 16 hours a day, 5 days a week, 50 weeks out of the year? You have no time to live your life, to do the things you want to do that besides programming. You have no time to hang out with your friends, your loved ones. Find an environment that works for you. Again, going back to the jerks. If your coworkers are complete jerks, odds are you're not going to like it there. You're going to go, how long do I have to work until I can jump ship to another job where I don't have to deal with butt munches? And your bosses too. If you have an office-based boss, that's not an enjoyable thing. You want a good boss that actually understands how to program, understands what it entails. Because if your boss says, "Oh, just open up Word and make a program," yeah, you don't want that. You want good quality bosses that understand programming, that understand you. Because if you don't have that, it's not going to be long before you dread going into work every day, and you don't want that. You actually want to enjoy your life. Also, advocate for yourself. Most people, your HR department, they're not for you, they're for the company. If you want a raise, you have to ask for it. You can't just expect one. Unfortunately, with a lot of the software engineering companies, if you want that nice raise, you have to unfortunately jump ship, and you have to switch companies. think it was 2 years was the average time that a person will stay at a company for like about 20 years at a time. So your average software engineer has somewhere between 6 and 10 different jobs they've worked at, because if they want that $10,000, $15,000 raise, they have to jump the ship for it. It's not just for trying out new things, going, oh, I don't like this, but you have to advocate for yourself. You can't just sit back and go, oh yeah, the company will treat me fine. Because if you can find a company that will do that, that's a really great company. But unfortunately, a lot of the startups, the mid-range companies, they're looking out for themselves. They're looking out for their profit margins. They're doing all of that things, and you're a vital part of that, but you're a part of that. You're not the whole thing. So you have to constantly be on vigil, watching out for yourself. Money is great, but it's not everything. It doesn't matter if you're making 150 grand a year if you're working 16 hours a day, 5 days a week. You're never going to have a chance to actually enjoy that money. So the money is good, great. If it's not, but it's something you enjoy doing, something 5 years down the road you can see yourself doing. You know you're not going to be waking up every morning going, crap, I have to go to work. You want a job where you can wake up in the morning and go, yes, I get to go to work, and be happy, having fun at work. So again, the money is nice, but your CS majors, odds are, most jobs with CS majors are very well compensated for the areas they live in. So again, money is not the greatest thing ever. It's important, but never let that be like the sole deciding factor of what you do. Because every person I've ever met that has done that has been a miserable sad sap. And I think we have hit Futurama, because I think that was the end. So anybody have any general questions? Only 10 minutes early.
What languages do you program in?
I use, let's see here, C, C++, Objective-C, Python, Java. Used a little bit of Go, not a lot. Some Bash scripting, and a lot of Linux commands. So pay attention in 210, because Linux is awesome.
Where do you get an internship at?
There's all sorts of places that are hiring. I know the job fair, I saw the email this morning. Job fair is next week, I think it is? Yeah, so next week. And there'll be places that are hiring. I know I got my first internship at M Foundry, which is now FIS, at the job fair. Met an old SSU student, Jeff, who worked there. He still works there. Showed up, we talked, gave him my resume, did the interview, and, got the internship, hung out there for a summer, did some pretty cool stuff. So I mean, and if it looks like a place that's hiring, I know Dr. Kushesh gets a lot of those emails. She shoots them out. Pay attention to those. Shoot the person in the email your resume. Call them up. They're all over. You just have to look for them. But yeah, getting that experience is so vital. Yes. I think I saw another hand, but did I answer your question?
Tim, tell us what you do for fun.
If you've caught it, Smash Brothers. I got that for Christmas. That's a stupid amount of fun. One of the reasons why I'm still up here and haven't moved down to actually Silicon Valley proper is I enjoy camping. It's kind of hard to do that down in Silicon Valley because there's concrete, not trees. But yeah, that, reading, other fun things. Probably spend 5 to 15 hours a week outside of work just figuring cool things out with other languages and stuff that I'm not using, just because it amuses me. But
do you use the agile development process at work?
No, because I'm the sole programmer. So I'm not my own boss, but I have quite free reign to do what I think is best. Most of the time it works out. Sometimes I have to go back and fix some things because I realized, down the road after more research, oh crap, that wasn't the smart thing to do. So you have to go back and fix it. But yeah, the other places I've worked at, mFoundry and MicroView, both use some variant of Agile, much more at mFoundry. But yeah, odds are, unless you're the sole developer there, you're going to have a project manager who gets together with other project managers and the team leads and figures out everything that needs to get done and breaks it up for you ahead of time. And then you get divvied out the individual projects that you work on for a day or two. You constantly are stand-ups once a day, figuring, hey, I did this, you did that, awesome, I'm stuck, give me some help, I'm done, yes, you get the next project. Projects are, at least from my experience, have been a day or two. Rarely are they much longer than that, simply because they've already been pre-broken out into nice little segmented chunks for you.
One more question, Tim. What, if you could, what would one change that you would make?
Honestly, pay attention more in class. Not gonna lie. Once I got my laptop, Reddit, Facebook, and then I'd be kicking myself because that evening start doing a project. Oh, I must have missed when they covered that crap, and then you have to go back and reteach it to yourself when you're paying attention in class. You wouldn't have to do that. But yeah, pay attention to class.
Your favorite and least favorite CS class?
Let's see here. Favorite probably would have been Capstone, simply because the project I worked on was Magic the Gathering related and had a heck of a lot of fun with that. Least favorite would probably be Theory of Comp, simply because that class is incredibly hard, and if you miss a class, you don't pay attention, you constantly kick yourself in the butt, because that class moves so fast.
Do you have any advice for balancing your computer science coursework with other coursework?
Because I was a bio major, and so I had done most of my GE, so I only had like 2 GE classes left. So I didn't really have that much problem because I crammed 4 years of CS classes into 2.5 years. But odds are, my advice would be, if you're passing your other classes, awesome. It's what I did with my European music class. It's like, I'm passing. Yes, more theory of comp work. Because, as long as you're passing, I don't think most employers are going to be like, so what did you learn about the history of Hawaii? You don't want to fail them, you want to give them time they deserve, but at the same time, you are CS majors. It makes at least more innate sense to me to spend the bulk of your additional time on your CS classes, making sure you understand the material and you're rocking it.
Did you ever have to learn or use Scala?
I played with it for a couple of hours, but no. But yeah, I did play with it for a little bit, but never had a reason to use it very much. Oh.
Just based on your experience here, how easy or hard was it to make the transition going from like the wear and tear from just like the school life to going into the workforce?
It was pretty easy for me at least, because I went to school full time and then I always had 20, 25 hour a week job. So I was already kind of doing it, but then I got more free time because I didn't have school. But with CS, it's not a huge difference. It's just instead of 3, 4, 5 subjects at a time, you're focusing on like one thing at a time. So you don't have to spend the time going, oh, I'm doing data structures right now. Next hour I'm going to do database. You can just go, I'm doing this, and you do it all day long. So it can be a little bit weird because you're now all of a sudden spending a lot more time on a single subject. But at the same time, it's kind of nice because you fall into those grooves and you just work and you look at the clock, you're like, oh crap, I should have gone home like 3 hours ago. But yeah, so that was really the big difference.
Were you nervous to go into your first internship?
Oh, I was terrified. I'm surprised I didn't piss my pants. My first interview at mFoundry was first it was 3 interviews in a row with one of the team leads that I was one of the teams I was potentially on, and it was bing bang boom, whiteboard, pseudocoding out in not an actual language, but just like pseudocoding, going, oh, that doesn't really work right there. You should probably fix that. And then thankfully the next interview was the next ex-SSU student who's basically, cool, let's chat. Basically figuring out who you are, whether or not you're a good fit. 'Cause, I mean, that's what so many companies are looking for, is who you are as a person and whether you fit with the rest of the teams. Because I think a lot of people, or a lot of companies are willing to go with somebody who, again, is a little bit less skilled, but a much better fit and willing to learn and work hard than if somebody is super smart and a complete jackass. And then, the third interview for that one was a shorter Eastern European man who was absolutely terrifying. I think
Do you have any advice for like people finishing up at SSU? Just kind of get into the working industry, like where to apply and all that good stuff.
Again, watch out for Kushesh's emails, because a lot of the times, a lot of people or companies will use internships as kind of a, oh, we're going to see if you fit. Oh, turns out you're actually good. We're going to steal you, and before you actually make it out into the world. I knew 8 people who actually had like full job like lined up before they graduated, just because of the internships. Because the companies went, you're a good person, we're totally kidnapping you. But Monster, Indeed, a lot of those other sites, they're constantly posting interviews, or not interviews, but job postings. Just look at them, figure out if it's a fit for you. I know 2K, last couple months ago, had a couple of not internship, but like fresh grad level jobs open, so that might be a good one. But just constantly keep a lookout, and also again your CS majors. So if you have a subject that interests you, check companies that do that, see if they have job openings, because odds are they're going to have something up your alley. Maybe not a full-on developer, but a system admin, something like that.
Having had quite a few jobs in my life, what you just said about trying to find a fit is important. And with respect to interviewing, don't forget that you're interviewing the company.
Yeah, always.
This is a two-way street.
Yeah, exactly. If your boss comes off as a complete jerk, maybe you don't want to work for him. Always do your research on the companies you interview ahead of time, so you know exactly what they do, how they kind of operate. Because they might ask you questions, and if you go, "You're hiring, and I want a job," that's probably not what they want to hear. I mean, odds are they probably want to hear that you're interested in the line of work that they're doing. Always. And also it helps, if you don't like a company's politics and you've researched them ahead of time, and you find out, oh, hey, I don't like those politics. Not to apply there. Those sorts of things. But definitely, it comes back to advocating for yourself. If you're not happy, you're not going to code well, and coding well is the important thing.
Tim, thanks very much.